Chapter 9 homework questions 1, 5, 11, 18, 26, 27, 28, and 29. Question 1. What's the meaning of null hypothesis? Null hypothesis is a hypothesis which is tested. An alternative hypothesis is a hypothesis which is considered as an alternative to the null. Test statistic is the statistic used as a basis for deciding whether null should be rejected. Significance level is the probability of making a type 1 error, which is like you reject the null, the true null. Two types of incorrect decisions can be made, which are type 1 and type 2. So the meaning of type 1 is it's the incorrect decision of rejecting a true null, and type 2 error is the incorrect decision of not rejecting a false null. And the letters we use for type 1 and type 2 are alpha and beta. This is for type 1, this is for type 2. If the null hypothesis in fact is true, only one type of error is possible, it's type 1. If you fail to reject the null, it's going to be type 2. The following graph is the decision criterion for a one-mean-z test using the critical value approach to hypothesis testing. The curve in the graph is the normal curve. Okay, so this is the graph, and in this graph, what is the rejection region? It's the part which is greater than or equal to 1.25. This part is the rejection region, and non-rejection region is the part which is less than z equals 1. Z is less than 1.28. The critical value is exactly at z equals 1.28, and the significance level is 0.10 because this is what we have in here. And when we graph it, this is how we graph all these: the non-rejection part, rejection part, critical value, and the significance level. And what type of hypothesis test we uses for this is definitely right-tailed. In each part, we have given the value obtained from for the test statistic z in a one-mean-z test. We also have specified whether the test is two-tailed, left-tailed, or right-tailed. Okay, now let's see that. Determine the p-value in each case and decide whether at the 5% significance level the data provides sufficient evidence to reject the null. So if we have z equals -1.25, and if it's left-tailed test, we do not reject the null because the value is going to be negative. Is going to be 0.1056. If z is 2.36, and if it's right-tailed test, we reject the null because this is what we get. And when z is 1.83, and if it's two-tailed test, again we do not reject. This is the value that we have. Question 26. The research says that the average American consumed 30 pounds of cheese in 2001, and actually it increased from 1960, where it was 8.3. Now it says that suppose that you want to decide whether last year's mean cheese consumption is greater than 2001. So what we do is for this statement, how do we identify the null? If it says check if it's greater than 30, well, the null says that it's equal to 30, so there's no change. And the alternative hypothesis should say that it's greater than 30. And the type of the test, hypothesis test, is going to be a right-tailed because it says it's greater. For the same question, the null is mu is 30, alternative hypothesis is mu is greater than 30. So how do we explain the type 1 error according to this? The type 1 error is going to be mu is actually 30, but the results of the result that we get leads us that it's greater than 30. Type 2 error is going to be actually mu is greater than 30, but the results that we get makes us fail to get this conclusion. And the correct decision of this is going to be mu is 30, and the results we get leads us do not lead us to reject this. And or actually mu is greater than 30, and the results that we get leads us to have this conclusion. Now suppose that the results of carrying out the hypothesis test lead to rejection of the null. Now if it's the rejection of the null, and if we say that it has not increased from 2001 mean of 30, then we say that it's type 1 error. But if we say that it has increased from the 2001 mean, then it's going to be a correct decision. Question 28, for the same question, now there's a sample, 35 randomly selected sample. And for this sample, at the 10% significance level, when we do data provide sufficient evidence to conclude that last year's mean cheese consumption has increased. And these are the values for the data. So the null is going to be mu is 30, alternative hypothesis mu is greater than 30. Alpha is, because it says 10% significance level, alpha is 0.10, z is 3.26, and the critical value is going to be 1.28, and the p-value is going to be 0.0006. So when we compare all these, we reject the null at 10% significance level, and we say that the data provides sufficient evidence to conclude that last year's mean cheese consumption for all Americans has increased over the 2001 mean of 30 pounds. For the same data, given the conclusion in part A, if an error has been made, what type of error would that be? It's going to be definitely type 1 error because the null was rejected, and the only error that could be is going to be the error of rejecting the true null hypothesis. Question 29, purse snatching. The Federal Bureau of Investigation compiles information on robbery and property crimes by type and selected characteristics and published its finding. So according to that document, the mean value lost to purse snatching was $417 in 2004. In last year, 12 randomly selected purse snatching offenses yielded to following values lost to the nearest dollar. These are the values. For this data, use a t-test to decide at the 5% significance level whether the last year's mean value lost to purse snatching has decreased. So the null is going to be mu is still 417, alternate hypothesis is less than 417 because it says 5% significance level, alpha is 0.05, and when we look at the table, t value is going to be negative 0.52, and therefore the critical values are going to be negative 1.796, and this is the p-value. So when we compare all this, this is the p-value, it's greater than the alpha, which means that we do not reject the null, and the data do not provide sufficient evidence to conclude that last year's mean value lost per snatching has decreased.